Okay, vector proofs. These can be a little bit fiddly, just warning you. So I'll go through 3 actually, and then I'd like to have a go at a few. So the first one's hopefully not too bad. So consider the triangle OAB. So triangle OAB with OA is equal to A, so position vector of A, lowercase a, and position vector of B, lowercase b, and C divides AB in the ratio of 1 to 2. So we'll put C there, so in the ratio of 1 to 2. And we want to find OC in terms of A and B. So this is a bit like what you were doing earlier on, but with the numbers. And so to find OC, we need to go from the origin to A, so we're travelling along vectors, and then we want to go 1/3 of the way along AB. Alternatively, you could go from the origin to B and then 2/3 of the way along BA, and you will get the same answer. So origin to C is equal to position vector of A, and then vector AB is position vector of B minus the position vector of A. And so OC is equal to A plus 1/3 B minus 1/3 A. And so OC is equal to 2/3 A plus 1/3 B. Right, next one. So now we have that C divides AB in the ratio of 3 to 4. So I'll put C there, so in the ratio of 3 to 4. M is the midpoint of OB, so M is half the way along OB, and OC and AM intersect at X. So OC and AM intersect here at X, and we want to find OX in terms of A and B. Now the trick with these is to find 2 different ways of getting from the origin to X. So I need to really use this line here to get from the origin to X, and I also need to incorporate using this one here. So we've got 2 different ways of getting from the origin to X, and then you can equate them together to find unknowns. You'll see what I mean when I go through it. So to start with, I know that OX is equal to a fraction of OC. And I'm going to use this Greek letter lambda here, only because it tends to be used for these, so just so you get used to it. Where lambda is a constant, and it's going to be between 0 and 1, so it's a fraction of OC. And then we know that to get from the origin to C, we need to go from the origin to A plus 3/7 of the way along AB. So I need to try and get this in terms of the vectors we know. So I need to try and get all of this in terms of A and B. So we know that the vector takes you from A to B. So OA is position vector of A. And the vector that takes you from A to B is the position vector of B minus the position vector of A. And then tidying up that bracket, I've got A minus 3/7 A, which is 4/7 A, plus 3/7 B. And then if I just times 3 by this lambda, then I've got 4/7 lambda A plus 3/7 lambda B. So that's one way of getting from the origin to X in terms of A and B. The other way I could go, we need to use this one here really. So if you've got two different things cutting through the shape, use one and then use the other, and that will serve you well as well. So I can go OA, AX. I could also go OMMX, which would come out really similarly to going OA, AX. So going that way through, then I know that OX is equal to OA plus a fraction of AM. So OA plus a fraction of AM, and this time I'm using Greek letter mu for that constant. And then position vector of A is A, and then the vector takes you from A to M is the position vector of M minus the position vector of A. So this is A plus mu, lots of OM is a half B, because we know this is a halfway along OB, and OA is position vector of A. And then tidying that lot up, I've got A minus mu A, which will give me 1 minus mu lots of A, plus a half mu B. And that's a different way of getting from the origin to X. So these two things need to be the same, and so we can match up coefficients now. So we need 1 minus mu to equal 4/7 lambda, because we need to go the same fraction along A for both of them. So that's one equation. And then matching up these ones, a half mu is equal to 3/7 lambda. And so if I times that one through by 2, then mu is equal to 6/7 times lambda. And then I can substitute in 1. So I'm just solving these equations simultaneously. And then you get 1 minus 6/7 lambda equals 4/7 lambda. And that will give you 1 is equal to 10/7 lambda. And so lambda is 7/10. And if lambda is 7/10, then that makes mu 6/10, substituting into 2. And then to find OX in terms of A and B, I can now just substitute mu into here. So 1 minus 6/10 is 0.4. And then a half mu is 0.3. And so that's OX in terms of A and B. I've done another video as well, another similar one for you to watch next lesson. But you need to find 2 different ways of getting from the origin to X. Set up 2 simultaneous equations by equating the coefficients, solve them and substitute back in. Obviously if you put lambda in here, that's going to give you 0.4a plus 0.3b, so you could substitute into either of them. What do you think about that one?